Hello, and welcome to the latest edition of Pandemic Education. I'll be your host, Colin Doolittle, and today we're going to talk about an introduction to trigonomic functions. So we're going to Unit 33. After I go through this unit, obviously you do the end of the chapter review, but I will have another paper that I'm going to send you, another handout for you to work on. It has both the questions and the solutions, so you can check yourself and kind of work a little more on these techniques. The reason I'm sending you the extra is since we're not in class, it makes it just more difficult for us to kind of get through some of these hurdles. So I'm just trying to give you all the resources I can. All right, so let's give this a whirl. There we go. Identifying the sides of a right triangle. So the sides of a right triangle are named the opposite side and the adjacent side and the hypotenuse. The hypotenuse, as we've talked about before, is the longest side. No ifs, ands, or buts. The position of the opposite and adjacent sides depend on the reference angle. That is the angle that we are looking at. It may be the angle we're trying to find, or it may be the angle given that we're going to use to find a side. So the opposite side is the opposite to the reference angle, and the adjacent side is next to the reference angle. Let's take a look and see how this looks. All right, so I know how much you guys like my writing. All right, so if our reference angle is right here, okay, what side is opposite to it? Let's call it side A. Okay, that is opposite to angle A. Adjacent means next to. Well, B is next to angle B, all right? Now, if we move angle B, now what was adjacent over here, if we're looking at this angle right over here, what was adjacent to angle A is now the opposite, goes right across, of angle B, okay? And then B, this side right here, is now adjacent. So the note at the bottom is very important. The opposite and adjacent sides vary depending on the reference angle, while the hypotenuse stays the same position in both cases. The other thing we need to know, or just to remember, maybe it's a triangle looks very close in the length of sides and all of that good stuff, the hypotenuse will always be across from the right angle, always be across from the 90 degrees, all right? So this is what we call SOHCAHTOA, all right? SOHCAHTOA is just an abbreviation. So SOH, so S-O-H-E, O-O-H, I don't know why I said E. Okay, is that. It is the sine of theta, theta being this Greek symbol here. The sine of theta is equal to the opposite side over the hypotenuse. And the opposite side into relation to theta, or what is also the angle, okay, of the reference angle. Okay, so it's opposite. Cosine, abbreviated as COS, is, and that's what we call CA. Yeah, that's awesome. Is equal to, cosine is equal to the adjacent side over the hypotenuse. And finally, we come to tangent. Okay, the tangent of theta okay, that is, tangent is equal to the opposite side over adjacent. So the way that I was taught to remember it, just in my head, is SOHCAHTOA, all right? It's just abbreviation. If you haven't heard it and you start dealing with a little bit of trig, it'll be a very common theme to talk about. All right, so then we have the reciprocals of sine, cosine, and tangent. Okay, so if tangent is opposite over adjacent, then cotangent is adjacent over opposite. If secant is cosine is adjacent over hypotenuse, our secant is now hypotenuse over adjacent. And then cosecant, if sine is opposite over hypotenuse, cosecant is hypotenuse over the opposite side. Do not ask me why they're called that. I have no idea, but that is what they're called. So it says, with the sides of the triangle below are labeled with different letters, state the ratio of each of the 6 trigonomic functions in relation to angle 1. All right, well, so let's try this. All right, so we've got angle 1. So right now, S is opposite to angle 1. All right. Let me try this with this. No, that won't work either. It's fine. S is opposite, I is adjacent, and M is the hypotenuse because it is across from there. All right, so if we're talking about functions, we have 6 functions, right? We've got sine, cosine, tangent, cosecant, secant, cotangent. All right, so we said sine in relation to this would be opposite over adjacent. So sine is opposite over hypotenuse. So if we look at S, which is opposite, and M, which is the hypotenuse, it is S over M. Cosine, well, let's go with cosecant now, which is just the reciprocal, so M over S. Okay. Now if we look at cosine, that is adjacent over hypotenuse. That would be I over M. And secant, which is hypotenuse over adjacent, it's M over I. It's the reciprocal. And finally, tangent, that's simply opposite over adjacent. So opposite of 1 is S, adjacent is I, so it's S over I. And cotangent, just flip it, I over S. It is the reciprocal. Look at that. Huh? Good job, us. Since we are learning about sine, cosine, and tangent, and secant, cosecant, and cotangent, as well as arcsine, arccosine, arctangent, I thought we would talk about how to use different calculators. So in this case, if I'm looking for the sine of 80, on this calculator, I'll hit the sine button and type in 80, and then close my parenthesis, hit enter, 0.98. Okay, come over to graphing calculator. I'm going to hit the sine key again, type in 80. Now, well, let me back that up, sorry. Close that parenthesis. Should come with the same answer. Oops. Sorry, trying to do this without looking. 0.984. Now on this calculator, if I hit the sine button first and then type 80 into the calculator, excuse me, we gotta type 80 first, and then on this calculator, I'm going to want to hit sine after that, and then it will give me a 0.984. If I did the reverse and said sine, then type in 80 and enter, it just gives me 80 over and over again. All right. So that is the use of like the sine key. The tangent key is going to be no different. The cosine key is going to be no different. But there is something else. So now let's look at arc sine or arc cosine. We'll take the sine function. Sine equals the opposite over the hypotenuse. All right, so let's say my opposite is 8 feet, and since it's over the hypotenuse, and the hypotenuse is 12 feet, enter. Well, 0.6666 cannot be the angle. The angle looks like it's, 80 degrees or 70 degrees or whatever. It definitely doesn't look like it's 0.666 repeating. So what we did wrong is to find that, we wanted to use the arc sine key. All right, we can do that, arc sine, and then I'm going to do 8 divided by 12. Make sure you close that parenthesis and hit enter. Oops, keep doing that, sorry. And then hit enter. 41, okay, or 41.81. That seems like a much more related to the angle you're looking at versus a decimal angle or a fractional angle. So these are some keys just kind of look at. If you have more specific questions, feel free to contact me, but we'll go from here. Thanks. Determining the function of the given angles is readily accomplished using the calculator. Procedure for determining the sine, cosine, and tangent functions. Note the procedure for determining functions of angles varies with different calculators, and I'll have a little video cutting in somewhere around here to talk about that. The value of the angle key first entered and then appropriate key function is pressed. That's one type of calculator. The other, the appropriate function key, is pressed first and then the value of the angle is entered. That's your main two types. So it says determine the sine of 61 degrees and 49 minutes to 5 decimal places. So the calculator I like to use, I'm going to hit the sine function first, which is sin, which is not sin. Don't call it sin. So I'm going to go sine, and I'm going to do my 61, 49, and I end up with 61.816667. Okay. If you did not end up with that number, if you ended up with the same number, that means you have to put the number in first, then hit the sine key. All right. So now it wants to find the value of the function. Okay. So the value of the function is, okay, I have 61.8667 degrees. All right. And it wants to know what the value of that is. It is going to be, when you put it in, 0.88144. Okay. And that is the value of that function. All right. Notice that it is a decimal, and it's going to be a decimal between 1 and -1. All right. The value of that function. So if you want to find secant, cosecant, secant, and cotangent functions, they're telling you to press 1 over x. What I would do is just know that cosecant is the opposite of sine, and secant is the opposite of, or the reciprocal, sorry, I should say reciprocal, of cosine, and cotangent is the reciprocal of tangent. Just flip it and then put it in. Not a big deal. The only case that this would work is if you don't have both sides and they're just asking you to do the function, then you would press the 1 over x key. So it says determine the cotangent of 78.36. So go ahead and type in the number, then hit the 1 over x, and we come up with 4.972884, just like that. Okay, and then the reciprocal of the answer, flip it, cotangent of 78.63, 0.201090. That's where that 1 over x comes into play if you're given nothing but the angle and they want to know the cotangent. It says angles of given functions. Determine the angles of a given function is the inverse of determining the function of a given angle. So when certain function values is known, the angle can be found easily. So the term arc, and in my video I talked about arc and the arc sign. So such expressions are called inverse functions, and they mean angles. Arc sign is often written as sine to the -1, or cosine to the -1, arc tangent to the -1. All right. With most calculators, the inverse functions are shown in the second mode, or I know the one 30x Pro, 30x, 36x Pro, you'll see sine, and then you'll see above it like cosine on the same key, on the actual key, and then sine to the -1. All you do is hit it twice. You don't have to hit a second function or anything of that nature. So it says find whose tangent is 1.902. All right, so in our calculators, we are just going to do, for me, I'm going to do second tangent 1.902, enter, 62.27 degrees. All right. Another calculator, I put the number in first, then hit tangent to the -1, or second tangent -1, and it comes up with the same answer. And this does give both examples. All right, so the secant, we've got to do our 1 over x key, and then second cosine to the -1, and we get our answer 35.37, or shift cosine to the -1, and then you just have to mess with the operations, but the answers are right there. So it says the side of the triangle below are labeled with different letters. State the ratio of each, okay, into relation to 1. And we did this just before, okay? So if we look at our opposite is y, our adjacent is x, and our hypotenuse is r, opposite of the right angle. All right, so if I want my sine, that's what? Opposite over hypotenuse, right? So that is going to be y over x. Cosine, adjacent over hypotenuse, so that, that first one should have been y over r. Second one will be x over r. And then the third one will be y, tangent will be y over x. Look down here, y over r, x over r, y over x. And then r over y, r over x, x over y. A lot of this chapter is just about getting used to the functions and setups. So it says, hey, find angle rounded to the nearest hundredth of a degree. So in this case, we're going to use our arc functions, okay? So if we look at this, 71.8, 41.7, or what, I guess, yeah, 74.11, 29.36, and 11.61. So these, again, are only calculator problems. So this is just to get started and used to it. The next chapter is when we'll really get into actually figuring out triangles themselves. So practice the functionality, practice the keys, and I will give you another handout talking about this stuff. And the next lecture will go a little better. I've got some new technology coming that's going to help us out. So in the meantime, this is the start, and we'll take it from here. Talk to you.